Welcome to clickmyproject.com.
Now we discuss about the process of hybrid HVDC system for power transmission to island network. The total installed rating of high voltage direct current scheme using line commutator thyristor converters has now reached almost 16 gigawatts. This technology is often the most economic means for transmission of power over long distance and or for interconnection of two synchronization AC network. This converter need AC voltage to commutate and therefore they cannot supply power to networks without synchronization machines. Voltage source converter based transmission scheme using voltage source converter with self-commutated devices such as insulated gate bipolar transmitters and gate turn-off thyristors provide a technical solution to this problem. However, the VSC transmission solution has higher cap- capa- capital cost and higher power loss than a thyristor-based line computed HVDC solution. Synchronization or static compensator have been proposed to enable line commutator HVDC converters to be connected to very weak AC networks. A new hybrid HVDC interconnector which combines the best feature of line computed HVDC and VSC technologies. In proposed newspaper, the system compares a thyristor HVDC converter with series capacitor and VSC based STATCOM and can be used for connecting island loads to a main grid. The STATCOM can be based on the chain link topology, which has very low power loss, or other VSC topologies such as the two-level or multi-level converter. For any case, as the STATCOM is rated much smaller than the whole scheme rating, it gives an overall power loss which is substantially lower than that of a pure VSC transmission game. The proposed system can be used for any power level and or schemes using overhead lines or cables because of the use of the series capacitor which has HVDC converter. No switched capacitor banks are required for common set in the hybrid system, minimizing the area occupied and the complexity of the power circuit. This paper describes the principle of proposed hybrid system and its main control strategy records the AC voltage control and automatic power balancing. The Simulink is used to validate the system performance under various operating conditions. A hybrid system comparing a line computed thyristor high voltage direct current converter and a static VA or compensator is proposed in this paper for the connection of networks with no synchronization generation to the main grid. The proposed system combines a robust performance and a low capital cost and power loss as a line computed HVDC converter. The fast dynamic performance of voltage source converter with transmission system describes the principle of control strategy of the proposed system by using the MATLAB Simulink are presented to demonstrate the robust performance and to validate the proposed system during various operating conditions such as black start, variation of the load and generation under the AC fault condition. And now it is the flow diagram for our proposed work. In this flow diagram, the AC source will be moved to the HVDC transmission line. First, the AC source will be converted to the DC by using the inverter. The inverter will be acting the 12 level thyristor controller. The thyristor will be controlled to the 12 level pulse of output and the output of DC will be transmitted and after transmitted sending and converted the DC to AC by using the normal 6 level inverter. The 6 level inverter will be controller based on the controller circuit and also the STATCOM will be interconnected to the circuit for maintaining the frequency range. And then after the DC transmission line it will be converted to the AC and it's a voltage grid and to check the balance and generate the DC pulse for the maintain the frequency of the overall process. The 12 pulse thyristor will be independently working based on the pulse width modulation, but the output of the DC to AC inverter will be working with the controller based output. So the output AC frequency will be maintained at particular level of harmonic Now we go to see demo of our Simulink model. In our Simulink model, we use the two different AC 3-base source will be used. So that reason it is called the hybrid HVDC transmission line. The 3-base AC source is the getting from any type of normal source in real time. The 3-base source will be go to the 6-level thyristor based inverter. The both AC source will be interconnected here by the DC output. The thyristor will be independently control the normal pulse with modulation, and the output of the thyristor, the capacitor will be added. That capacitor will be improve the or lower the harmonic level of the DC voltage during the inversion process. Here the both output will be interconnected. So overall we see it is the 12 pulse thyristor controller, and the output will be came as a DC, and the DC will be transmitted, and finally it will be converted to the AC by the 12 level thyristor controller. Here the 12 level thyristor controller will be controlled based on the output voltage of thyristor, and the thyristor voltage, the current will be going to the controller circuit, and the controller circuit generates the pulses based on the output of output voltage and output current, and also the thyristor voltage and thyristor current, and it will generate the pulses of 12 pulse thyristor, and it will be maintain the frequency of the output AC source. So the output AC source will be low frequency because the 12 pulse thyristor inverter will be improve the low harmonic level. Then after it will be cross the RL circuit. The RL circuit is help to remove the unwanted harmonics in the process. After, the grid load will be connected to the main circuit, and then the STATCOM will be connected to the breaker circuit. If any frequency will be low in the main circuit, then the breaker switch will be on, then the STATCOM will be connected to the main circuit, the output will be maintained. Here the grid will be connected, there are different various load will be added, and then we find out the voltage and the current and the STATCOM voltage and STATCOM current and the reactive and reactive power for our process. In our process, the active and reactive power will be maintained by using the STATCOM. So it is the best solution for the long time transmission of HVDC. Thank you.